everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem using the method of undetermined coefficients. So let's get going. Problem solve y double dash minus 2y dash plus 3y equal to x cube plus sin x. So here we are given a differential equation in terms of y, and we are going to write this in operator form also. Okay. We are given y double dash minus 2y dash plus 3y equal to x cube plus sin x, right? We can write y double dash as d square y by dx square and y dash as dy by dx. So let's write it. We'll get it's 3y, right? Now let's use the differential operator. You can write d square y by dx square as capital D square y and dy by dx as capital dy. We'll get d square y minus 2 dy plus 3y equal to x cube plus sin x. Right? Fine. Let's take y common from all the three terms of LHS. We'll get d square minus 2d plus 3 into y equal to x cube plus sin x, which is an operator form. So we have written the given differential equation in operator form. Okay. Now coming to the problem. Given y double dash minus 2y dash plus 3y equal to x cube plus sin x, consider as equation number 1. And also we can write the same equation as d square minus 2d plus 3 into y equal to x cube plus sin x, right? Which is in operator form, which is of the form f of d into y equal to some function of x, say q of x, where f of d equal to d square minus 2d plus 3 and q of x equal to x cube plus sin x. Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find yc using auxiliary equation and later we'll go for yp. Okay, we can use direct formula or we can go for trial method. I'll prefer trial method, okay, which is safe. Fine. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 3, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 2m plus 3. Now the auxiliary equation becomes m square minus 2m plus 3 equal to 0. Now we need to find roots to this equation, so let's use quadratic formula. M equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay. Now compare this equation with quadratic equation in terms of m. Okay. A is the quotient of m square. B is quotient of m, which is minus 2, and C is constant 3. Now substitute these values here. Minus b plus or minus square root of b square minus 4ac by 2a, right? This gives us 2 plus or minus square root of minus 2 square 4 minus 4 3s are 12 by 2, which gives us 2 plus or minus square root of 4 minus 12 gives minus 8 by 2. We can write square root of minus 8 as minus 1 into 4 into 2. See, minus 1 into 4 minus 4 minus 4 into 2. Again, you'll get minus 8, right? Now split the square root. Since we know that Square root of minus 1 is I and square root of 4 is 2. We'll get 2 plus or minus I into 2 into root 2 by 2. Now take 2 common from the terms of numerator. You'll get 2 times 1 plus or minus I into root 2 by 2. These 2 gets cancelled and you'll get 1 plus or minus root 2I or I into root 2, a pair of complex conjugate roots. Therefore, m equal to 1 plus or minus I root 2, a pair of complex conjugate roots. We know that when m equal to a plus or minus ib, then yc looks like e power ax into one constant into cos bx plus another constant, say c2 into sin bx, right? Now with the help of this formula, we'll find our complementary function to our problem. Complementary function yc equal to e power, just compare 1 plus or minus I into root 2 with a plus or minus ib, then for a equal to 1 and b equal to root 2, we'll get a x into one constant is c1 into cos bx root 2 into x plus c2 sin bx, right? This gives us e power x into c1 cos root 2x plus c2 sin root 2x. So we got yc here. Or we can write yc as c1 e power x cos root 2x plus c2 e power x sin root 2x. Okay, fine. We have yc equal to c1 e power x cos root 2x plus c2 e power x sin root 2x. Also q of x equal to x cube plus sin x. Now observe the terms of yc and q of x in, the functions of x. Okay, we are having e power x cos root 2x, e power x sin root 2x, these two in yc, and x cube sin x in q of x, right? So by observing these two, we can say that no terms of q of x is common with terms of yc, right? Therefore, q of x has no common term with yc. Therefore, yp must contain the linear combination of q of x and all its linearly independent derivatives. Okay, fine. Let's see the formula first. When q of x is x cube, suppose if you have x cube, a term x cube in q of x, then yp will have the corresponding formula to x cube will be ax cube plus bx square plus cx plus d. Okay, when q of x is sin ax or cos ax, then yp will be a sin ax plus b cos ax. Okay. Now coming to our formula yp equal to, we have x cube, right? So let's write a formula corresponding to this x cube. I'll take one constant into x cube plus b, another constant into x square plus another constant into x plus another quotient say d plus, now let's write for sin x. Compare sin x with sin ax. For a equal to 1 we'll have yp equal to, for a equal to 1 we have yp equal to, put a equal to 1, that is small a equal to 1, then you'll have a sin x plus b cos x, right? Some other constants, say a1, b1, a, b, c, d, let's take e. We'll get e sin x plus f cos x. E sin x plus f cos x for sin x, corresponding yp to sin x, and corresponding to x cube is a x cube plus b x square plus cx plus d, right? This is our yp using the formula. Now let's see the trial method to find yp. We have x cube, right? Q of x has a term x cube. Let's find its derivatives. So yp should get q of x, terms of q of x and all its linearly independent derivatives. So we'll find derivatives of x cube now. Let's find derivatives of x cube. Derivative of x cube is 3x square. Derivative of 3x square is 3 2s are 6x. Derivative of 6x is 6. Derivative of 6, which is constant, 0. Again, here you'll get 0, 0, 0, 0 and so on. It continues, right? Fine. And here you're having sin x. Q of x has a term sin x. Find its derivative. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of minus sin x is minus cos x. Derivative of minus cos x is minus of minus sin x, which is sin x, right? And derivative of sin x is cos x. Again, derivative of cos x is minus sin x. It just repeats. You'll get sin x or cos x. While finding the derivatives of sin x, we'll get either sin x or cos x. Fine? Now, we'll write the terms of q of x and its derivatives in a set. Remember that this set should not involve any repeated terms. Okay. Now, I'm having q of x and all its derivatives here. So I'm picking one term. X cube, 1x square, x. Here it involves a constant, right? I'll write constant instead of 6. And no need to write 0, we wrote constant, right? Sin x, 1 cos x. So you're having x cube, x square, x, a constant, sin x and cos x, right? See, this set involves q of x. X cube, terms of q of x. X cube, sin x and all its derivatives, right? Derivative of sin x is cos x. Again, derivative of cos x is sin x. You have all the derivatives here. Likewise, derivatives of x cube, you have x, x square and constant. So we wrote q of x and terms of q of x and all its derivatives in a set form. Okay, we have expressed the terms of q of x and all its derivatives in a set form. Now with the help of this set, we'll write yp. Yp equal to, I'll pick x cube. X cube with some quotient say a plus x square with some quotient say b. You can take c1, c2, c3 or a0, a1, a2, anything instead of a, b, c, d. Plus x with some quotient say c plus, here you're having constant, right? So I'll take d instead of constant plus sin x with some quotient say e plus cos x with some coefficient, say f. Here a, b, c, d, e, f are undetermined coefficients. So we need to find the values of a, b, c, d, e, f. Fine. So we got the yp with the help of trial method. Now coming to the problem. Let yp equal to ax cube plus bx square plus cx plus d plus e sin x plus f cos x. Okay, let yp equal to ax cube plus bx square plus cx plus d plus e sin x plus f cos x such that it satisfies the given equation. Okay, so we can write the given equation in terms of yp. We'll get yp double dash minus 2yp dash plus 3yp equal to x cube plus sin x. It involves yp, yp dash and yp double dash. So we need to find yp dash and yp double dash with the help of this yp. So let's find yp dash and yp double dash. Yp dash equal to a into derivative of x cube 3x square plus b into derivative of x square is 2x plus c into derivative of x 1 plus derivative of constant 0 plus e into derivative of sin x is cos x plus f into derivative of cos x is minus sin x, right? This gives us 3ax square plus 2bx plus c plus e cos x minus f sin x. So this is our yp dash. Now let's find yp double dash. 3a into derivative of x square is 2x plus 2b into derivative of x 1 plus derivative of constant 0 plus e into derivative of cos x is minus sin x minus f into derivative of sin x is cos x, which gives us 3 to the 6ax plus 2b minus e sin x minus f cos x, right? One becomes, I'm writing 1 in terms of yp double dash, because we have picked yp such that it satisfies the given equation, so we can write the given equation in terms of yp. Okay, now substitute the values of yp double dash, yp dash and yp in it. We'll get yp double dash 6ax plus 2b minus e sin x minus f cos x minus 2 times yp dash 3ax square plus 2bx plus c plus e cos x minus f sin x plus 3 times yp ax cube plus bx square plus cx plus d plus e sin x plus f cos x equal to RHS part x cube plus sin x. Now simplify it. This gives us, just simplify it, 6ax plus 2b minus e sin x minus f cos x minus 2 3 is 6 ax square minus into plus minus 2 2 is 4 bx minus into plus minus 2c minus into plus minus 2e cos x minus into minus plus 2f sin x plus 3ax cube plus 3bx square plus 3cx plus 3d plus 3e sin x plus 3f cos x equal to x cube plus sine x, right? Now write the terms involving x cube first. We have 3ax cube. Now write the terms involving x square. We have minus 6a x square plus 3b x square. Now write the terms involving x plus 6ax minus 4bx plus 3cx. Now write the constants 2b minus 2c plus 3d. Now write the terms involving sin x minus e sin x plus 2f sin x plus 3e sin x. Now write the terms involving cos x, okay, minus f cos x minus 2e cos x plus 3f cos x equal to x cube plus sine x, right? We have covered all the terms, right? Fine. Now I'll write the term involving x cube as 3a into x cube, okay. Now I'll take x square common from the next two terms. I'll write it as plus of minus 6a plus 3b into x square. Now I'll take x common from the next three terms. 6a minus 4b plus 3c into x. Now write the constants 2b minus 2c plus 3d. Now take sin x common from these three terms. Minus e plus 12 plus 3e, it's e, right, into sin x. Now take cos x common from these three terms, plus of minus f minus 2e plus 3f into cos x equal to x cube plus sine x. Fine. Now simplify it. We need to simplify these two terms, okay? First 1, 2, 3, 4 terms remains the same. 3a x cube plus of minus 6a plus 3b into x square plus of 6a minus 4b plus 3c into x plus 2b minus 2c plus 3d plus of 3e minus e gives 2e plus 2f into sin x plus minus f minus 3f gives 2f minus 3e, sorry, it's 2e, right? You'll get 2e here, sorry. 3f minus f is 2f minus 2e into cos x equal to x cube plus sine x. Now equate the equations of like terms. Equating the equations of like terms. I'll begin with x cube first. You have 3a coefficients 1, which gives us a equal to 1 by 3. Now equate the equations of x square. minus 6a, it's here, right? Plus 3b equal to, we don't have any x square term, so take it as 0. Now substitute the value of a here. This gives us 3b equal to 2. From this we'll get b equal to 2 by 3. Now equate the quotient of x. 6a minus 4b plus 3c equal to, we don't have any x term in RHS part, so take it as 0. Substitute the values of a and b here. A is 1 by 3 and b is 2 by 3 plus 3c equal to 0. You can write this as 6 by 3 minus 4 2 is 8 by 3 plus 3c equal to 0. 6 minus 8 is minus 2. Now I'll take this term to RHS, we'll get 3c equal to 2 by 3. Now take this 3 to RHS, we'll get c equal to 2 by 3 into 3, 6, sorry 9. Let's write it. Right? Now we got the values of a, b and c. A equal to 1 by 3, b equal to 2 by 3, c equal to 2 by 9. Right? Fine. Now compare constants. You don't have any constant term in the RHS, okay? You get 2b minus 2c plus 3d equal to 0. Substitute the values of b and c here. b is 2 by 3 minus 2 into c, 2 by 9 plus 3d equal to 0. This gives us 2 2s are 4 by 3 minus 4 by 9 plus 3d equal to 0. Take the LCM of 3 and 9. Which is 9. We'll get 4 3s are 12. Here in the denominator first term you're having 3, so close 1 3 and multiply this 3 to the numerator 4. We'll get 3 4s are 12 minus here you're having 9, right? 3 3s are 9. So write this denominator as it is 4. This gives us 12 minus 4 is 8 by 9 plus 3d equal to 0. Can write it as 3d equal to minus 8 by 9. Now take this 3 to RHS, we'll get d equal to minus 8 by 9 into 3, which is 27, which gives us minus 8 by 27. So you got the value of d also, d equal to minus 8 by 27. Now equate the coefficients of sin x, 2e plus 2f equal to 1. Equate the coefficients of cos x, minus 2e plus 2f equal to, we don't have any cos x term in RHS, so take it as 0. Now by solving these two equations we'll get the values of e and f. Let's solve them. F equal to 1 by 4. Now substitute the value of f in this equation. You will get 1 by 2 equal to 2e, or just bring this 2 to LHS, you will get 1 by 4 equal to e, that is e equal to 1 by 4. So we got the values of a, b, c, d, e and f, right? Now coming to yp, we have yp equal to ax cube plus bx square plus cx plus d plus e sin x plus f cos x, right? Let's substitute the values of a, b, c, d, e and f. We'll get a 1 by 3 into x cube plus b 2 by 3 into x square plus c 2 by 9 into x plus d minus 8 by 27 plus e 1 by 4 sin x plus f 1 by 4 sin, it's cos x. Or we can write this as 1 by 3 into x cube plus 2 by 3 into x square plus 2 by 9 into x minus 8 by 27. Take 1 by 4 common from the last two terms. You'll get 1 by 4 into sin x plus cos x, which is the required yp. We got yp and yc. Let's now find the general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp. Then y equal to yc, c e power x into c1 cos root 2x plus c2 sin root 2x plus yp. 1 by 3 x cube plus 2 by 3 x square plus 2 by 9 x minus 8 by 27 plus 1 by 4 into sin x plus cos x, which completes the problem. So you can verify yp with the help of 1 by f of d into q of x, or we can write the given differential equation as yp double dash minus 2 yp dash plus 3 yp equal to x cube plus sin x, right? So consider the LHS part. Yp double dash minus 2 yp dash plus 3 yp. Find, see we have yp, right? The actual yp after substituting the values of undetermined coefficients. Find yp dash and yp double dash and substitute in it. Finally, you'll get the answer after substituting yp double dash minus 2 into yp dash plus 3 into yp. Finally, after simplifying this, you'll get x cube plus sin x. Okay, if you get this, your yp will be the correct one. So this is a verification process. Okay, if you want, you can check it out. Find yp double dash and yp dash with the help of this yp and substitute in LHS part of this formula. Finally, you should get x cube plus sin x. Fine. Well, we have seen a problem from the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.